A volcano is a rupture in the crust of a planetary-mass object, such as Earth, that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. Earth's volcanoes occur because its crust is broken into 17 major, rigid tectonic plates that float on a hotter, softer layer in its mantle. Therefore, on Earth, volcanoes are generally found where tectonic plates are diverging or converging. For example, a mid-oceanic ridge, such as the mid-Atlantic ridge, has volcanoes caused by divergent tectonic plates pulling apart. The Pacific Ring of Fire has volcanoes caused by convergent tectonic plates coming together. Volcanoes can also form where there is stretching and thinning of the crust's interior plates, e.g., in the East African Rift and the Wells Grey Clearwater Volcanic Field and Rio Grande Rift in North America. This type of volcanism falls under the umbrella of plate hypothesis volcanism. Volcanism away from plate boundaries has also been explained as mantle plumes. These so-called hotspots, for example Hawaii, are postulated to arise from upwelling diapirs with magma from the core mantle boundary, 3,000 kilometers deep in the Earth. Volcanoes are usually not created where two tectonic plates slide past one another. Erupting volcanoes can pose many hazards, not only in the immediate vicinity of the eruption. One such hazard is that volcanic ash can be a threat to aircraft, in particular those with jet engines, where ash particles can be melted by the high operating temperature. The melted particles then adhere to the turbine blades and alter the shape, disrupting the operation of the turbine. Large eruptions can affect temperature as ash and droplets of sulfuric acid obscure the sun and cool the Earth's lower atmosphere. However, they also absorb heat radiated up from the Earth, thereby warming the upper atmosphere. Historically, so-called volcanic winters have caused catastrophic famines. Etymology: the word volcano is derived from the name of Volcano, a volcanic island in the Aeolian Islands of Italy whose name in turn comes from Vulcan, the god of fire in Roman mythology. The study of volcanoes is called volcanology, sometimes spelled volcanology. Plate tectonics. Divergent plate boundaries at the mid-oceanic ridges. Two tectonic plates diverge from one another as new oceanic crust is formed by the cooling and solidifying of hot molten rock. Because the crust is very thin at these ridges due to the pull of the tectonic plates, the release of pressure leads to adiabatic expansion and the partial melting of the mantle, causing volcanism and creating new oceanic crust. Most divergent plate boundaries are at the bottom of the oceans, therefore, most volcanic activity is submarine, forming new seafloor. Black smokers are evidence of this kind of volcanic activity. Where the mid-oceanic ridge is above sea level, volcanic islands are formed. For example, Iceland. Convergent plate boundaries. Subduction zones are places where two plates, usually an oceanic plate and a continental plate, collide. In this case, the oceanic plate subducts, or submerges under the continental plate, forming a deep ocean trench just offshore. In a process called flux melting, water released from the subducting plate lowers the melting temperature of the overlying mantle wedge, creating magma. This magma tends to be very viscous due to its high silica content, so it often does not reach the surface but cools at depth. When it does reach the surface, a volcano is formed. Typical examples of this kind of volcano are Mount Etna and the volcanoes in the Pacific Ring of Fire. Hotspots. Hotspots is the name given to volcanic areas believed to be formed by mantle plumes, which are hypothesized to be columns of hot material rising from the core mantle boundary in a fixed space that causes large volume melting. Because tectonic plates move across them, each volcano becomes dormant and is eventually reformed as the plate advances over the postulated plume. The Hawaiian Islands have been suggested to have been formed in such a manner, as well as the Snake River Plain, with the Yellowstone caldera being the part of the North American plate currently above the hot spot. This theory is currently under criticism, however. Volcanic features. The most common perception of a volcano is a volcanical mountain, spewing lava and poisonous gases from a crater at its summit. However, this describes just one of the many types of volcano. The features of volcanoes are much more complicated, and the structure and behavior depends on a number of factors. Some volcanoes have rugged peaks formed by lava domes rather than a summit crater, while others have landscape features such as massive plateaus. Vents that issue volcanic material and gases can develop anywhere on the landform and may give rise to smaller cones such as on a flank of Hawaii's Kilauea. Other types of volcano include cryovolcanoes, particularly on some moons of Jupiter, Saturn, and Neptune, and mud volcanoes, which are formations often not associated with known magmatic activity. Active mud volcanoes tend to involve temperatures much lower than those of igneous volcanoes, except when the mud volcano is actually a vent of an igneous volcano. Fissure vents. Volcanic fissure vents are flat, linear fractures through which lava emerges. Shield volcanoes. Shield volcanoes, so named for the broad, shield-like profiles, are formed by the eruption of low-viscosity lava that can flow a great distance from a vent. They generally do not explode catastrophically, since low-viscosity magma is typically low in silica. Shield volcanoes are more common in oceanic than continental settings. The Hawaiian volcanic chain is a series of shield cones, and they are common in Iceland as well. Lava domes. Lava domes are built by slow eruptions of highly viscous lava. They are sometimes formed within the crater of a previous volcanic eruption, as in the case of Mount St. Helens, but can also form independently, as in the case of Lassen Peak. Like stratovolcanoes, they can produce violent, explosive eruptions, but the lava generally does not flow far from the originating vent. Cryptodomes. Cryptodomes are formed when viscous lava is forced upward, causing the surface to bulge. The 1980 eruption of Mount St. Helens was an example. Lava beneath the surface of the mountain created an upward bulge which slid down the north side of the mountain. Volcanic cones. Volcanic cones or cinder cones result from eruptions of mostly small pieces of scoria and pyroclastics that build up around the vent. These can be relatively short-lived eruptions that produce a cone-shaped hill perhaps 30 to 400 meters high. Most cinder cones erupt only once. Cinder cones may form as flank vents on larger volcanoes, or occur on their own. Paraquitan in Mexico and Sunset Crater in Arizona are examples of cinder cones. In New Mexico, Caja del Rio is a volcanic field of over 60 cinder cones. Based on satellite images, it was suggested that cinder cones might occur on other terrestrial bodies in the solar system too, on the surface of Mars and the Moon. Stratovolcanoes. Stratovolcanoes are composite volcanoes, are tall conical mountains composed of lava flows and other ejecta in alternate layers. The strata that gives rise to the name. Stratovolcanoes are also known as composite volcanoes because they are created from multiple structures during different kinds of eruptions. Composite volcanoes are made of cinders, ash, and lava. Cinders and ash pile on top of each other. Lava flows on top of the ash, where it cools and hardens, and then the process repeats. Classic examples include Mount Fuji in Japan, Mayon Volcano in the Philippines, and Mount Vesuvius and Stromboli in Italy. Throughout recorded history, ash produced by the explosive eruption of stratovolcanoes has posed the greatest volcanic hazard to civilizations. Not only do stratovolcanoes have greater pressure build-up from the underlying lava flow than shield volcanoes, but the fissure vents and monogenetic volcanic fields have more powerful eruptions, as they are many times under extension. They are also steeper than shield volcanoes, with slopes of 30 to 35 degrees compared to slopes of generally 5 to 10 degrees, and the loose tephra material for dangerous lavas. Large pieces of tephra are called volcanic bombs. Big bombs can measure more than 4 feet across and weigh several tons. Supervolcanoes. A supervolcano usually has a large caldera and can produce devastation on an enormous, sometimes continental, scale. Such volcanoes are able to severely cool global temperatures for many years after the eruption due to the huge volumes of sulfur and ash released into the atmosphere. They are the most dangerous type of volcano. Examples include Yellowstone caldera in Yellowstone National Park and Valles caldera in New Mexico, Lake Taupo in New Zealand, Lake Toba in Sumatra, Indonesia, and Ngorongoro crater in Tanzania. Because of the enormous area they may cover, supervolcanoes are hard to identify centuries after an eruption. Similarly, large igneous provinces are also considered supervolcanoes because of the vast amount of basalt lava erupted. Submarine volcanoes. Submarine volcanoes are common features of the ocean floor. In shallow water, active volcanoes disclose the presence by blasting steam and rocky debris high above the ocean's surface. In the ocean's deep, the tremendous weight of the water above prevents the explosive release of steam and gases. However, they can be detected by hydrophones and discoloration of water because of volcanic gases. Pillow lava is a common eruptive product of submarine volcanoes and is characterized by thick sequences of discontinuous pillow-shaped masses which form underwater. Even large submarine eruptions may not disturb the ocean surface due to the rapid cooling effect and increased buoyancy of water, which often causes volcanic vents to form steep pillars on the ocean floor. Hydrothermal vents are common near these volcanoes, and some support peculiar ecosystems based on dissolved minerals. Over time, the formations created by submarine volcanoes may become so large that they break the ocean surface as new islands are floating pumice rafts. Subglacial volcanoes. Subglacial volcanoes develop underneath ice caps. They are made up of flat lava which flows at the top of extensive pillow lavas and palagonite. When the ice cap melts, the lava on top collapses, leaving a flat-topped mountain. These volcanoes are also called table mountains, tulias, or mobigs. Very good examples of this type of volcano can be seen in Iceland. However, there are also tuyas in British Columbia. The origin of the term comes from Tuya Butte, which is one of the several tuyas in the area of the Tuya River and Tuya Range in northern British Columbia. Tuya Butte was the first such landform analyzed, and so its name has entered the geological literature for this kind of volcanic formation. The Tuya Mountains Provincial Park was recently established to protect this unusual landscape, which lies north of Tuya Lake and south of the Jennings River near the boundary with the Yukon Territory. Mud volcanoes. Mud volcanoes are mud domes or formations created by geo-excreted liquids and gases, although there are several processes which may cause such activity. The largest structures are 10 kilometers in diameter and reach 700 meters high. Erupted material. Lava composition. Another way of classifying volcanoes is by the composition of material erupted, since this affects the shape of the volcano. Lava can be broadly classified into 4 different compositions. If the erupted magma contains a high percentage of silica, the lava is called felsic. Felsic lavas tend to be highly viscous and are erupted as domes or short, stubby flows. Viscous lavas tend to form stratovolcanoes or lava domes. Lassen Peak in California is an example of a volcano formed from felsic lava and is actually a large lava dome. Because siliceous magmas are so viscous, they tend to trap volatiles that are present, which cause the magma to erupt catastrophically, eventually forming stratovolcanoes. Pyroclastic flows are highly hazardous products of such volcanoes, since they're composed of molten volcanic ash too heavy to go up into the atmosphere, so they hug the volcano's slopes and travel far from the vents during large eruptions. Temperatures as high as 1,200 degrees Celsius are known to occur in pyroclastic flows, which will incinerate everything flammable in the path, and thick layers of hot pyroclastic flow deposits can be laid down, often up to many meters thick. Alaska's Valley of 10,000 Smokes, formed by the eruption of Nova Rupta near Katmai in 1912, is an example of a thick pyroclastic flow or ignimbrite deposit, volcanic ash that is light enough to be erupted high into the Earth's atmosphere may travel many kilometers before it falls back to ground as a tuff. If the erupted magma contains 52 to 63% silica, the lava is of intermediate composition. These andesitic volcanoes generally only occur above subduction zones. Andesitic lava is typically formed at convergent boundary margins of tectonic plates by several processes: hydration, melting of peridotite, and fractional crystallization, melting of subducted slab-containing sediments. Magma mixing between felsic rhyolitic and mafic basaltic magmas in an intermediate reservoir prior to emplacement of lava flow. If the erupted magma contains an Lt 52% and an Gt 45% silica, the lava is called mafic or basaltic. These lavas are usually much less viscous than rhyolitic lavas. Depending on their eruption temperature, they also tend to be hotter than felsic lavas. Mafic lavas occur in a wide range of settings. At mid-ocean ridges, where two oceanic plates are pulling apart, basaltic lava erupts as pillars to fill the gap. Shield volcanoes, on both oceanic and continental crust, as continental flood basalts. Some erupted magmas contain an Lt equals 45% silica and produce ultramafic lava. Ultramafic flows, also known as cometites, are very rare indeed. Very few have been erupted at the Earth's surface since the Proterozoic, when the planet's heat flow was higher. They are the hottest lavas, and probably more fluid than common mafic lavas. Lava texture. Two types of lava are named according to the surface texture: AA and Pahoeho, both Hawaiian words. AA is characterized by a rough, clinkery surface and is the typical texture of viscous lava flows. However, even basaltic and mafic flows can be erupted as air flows, particularly if the eruption rate is high and the slope is steep. Pahoeho is characterized by its smooth and often ropey or wrinkly surface and is generally formed from more fluid lava flows. Usually only mafic flows will erupt as Pahoeho, since they often erupt at high temperatures or have the proper chemical makeup to allow them to flow with greater fluidity. Volcanic activity. Popular classification of volcanoes. A popular way of classifying magmatic volcanoes is by the frequency of eruption, with those that erupt regularly called active, those that have erupted in historical times but are now quiet called dormant or inactive, and those that have not erupted in historical times called extinct. However, these popular classifications, extinct in particular, are practically meaningless to scientists. They use classifications which refer to a particular volcano's formative and eruptive processes and resulting shapes, which was explained above. Active. There is no consensus among volcanologists on how to define an active volcano. The lifespan of a volcano can vary from months to several million years, making such a distinction sometimes meaningless when compared to the lifespans of humans or even civilizations. For example, many of Earth's volcanoes have erupted dozens of times in the past few thousand years but are not currently showing signs of eruption. Given the long lifespan of such volcanoes, they are very active by human lifespans. However, they are not. Scientists usually consider a volcano to be erupting or likely to erupt if it is currently erupting, or showing signs of unrest such as unusual earthquake activity or significant new gas emissions. Most scientists consider a volcano active if it has erupted in the last 10,000 years. The Smithsonian Global Volcanism Program uses this definition of active. Most volcanoes are situated on the Pacific Ring of Fire. An estimated 500 million people live near active volcanoes. Historical time is another time frame for active. The catalogue of the active volcanoes of the world, published by the International Association of Volcanology, uses this definition, by which there are more than 500 active volcanoes. However, the span of recorded history differs from region to region. In China and the Mediterranean, it reaches back nearly 3,000 years, but in the Pacific Northwest of the United States and Canada, it reaches back less than 300 years, and in Hawaii and New Zealand, only around 200 years. As of 2013, the following are considered Earth's most active volcanoes. Kilauea, the famous Hawaiian volcano, has been in continuous, effusive eruption since 1983, and has the longest observed lava lake. Mount Etna and nearby Stromboli, two Mediterranean volcanoes in almost continuous eruption since antiquity. Mount Yashua in Vanuatu has been erupting nearly continuously for over 800 years. The longest currently ongoing volcanic eruptive phases are Mount Yashua 111 years, Mount Etna 109 years, Stromboli 108 years, Santa Maria 101 years, Sangay 94 years. Other very active volcanoes include Mount Nyiragongo and its neighbor, Nyamuragira, are Africa's most active volcanoes. Piton de la Fournaise in our Irkut Union erupts frequently enough to be a tourist attraction. Erta Ale in the Afar Triangle has maintained a lava lake since at least 1906. Mount Erebus in Antarctica has maintained a lava lake since at least 1972. Mount Merapi, Fakarari, White Island, has been in continuous state of smoking since its discovery in 1769. Aldo Yolengai, Ambram, Arenal Volcano, Pakaya, Kliachevskaya Sobka, Sheveluch. Extinct volcanoes are those that scientists consider unlikely to erupt again because the volcano no longer has a magma supply. Examples of extinct volcanoes are many volcanoes on the Hawaiian Emperor Seamount chain in the Pacific Ocean, Hurntwil, Shiprock, and the Zoudwil volcano in the Netherlands. Edinburgh Castle in Scotland is famously located atop an extinct volcano. Otherwise, whether a volcano is truly extinct is often difficult to determine, since supervolcano calderas can have eruptive lifespans sometimes measured in millions of years. A caldera that has not produced an eruption in tens of thousands of years is likely to be considered dormant instead of extinct. Some volcanologists refer to extinct volcanoes as inactive, though the term is now more commonly used for dormant volcanoes once thought to be extinct. Dormant. It is difficult to distinguish an extinct volcano from a dormant one. Volcanoes are often considered to be extinct if there are no written records of its activity. Nevertheless, volcanoes may remain dormant for a long period of time. For example, Yellowstone has a repose-recharge period of around 700,000 years, and Toba of around 380,000 years. Vesuvius was described by Roman writers as having been covered with gardens and vineyards before its eruption of AD 79, which destroyed the towns of Herculaneum and Pompeii. Before its catastrophic eruption of 1991, Pinatubo was an inconspicuous volcano, unknown to most people in the surrounding areas. Two other examples of the long-dormant São Freire Hills volcano on the island of Montserrat, thought to be extinct before activity resumed in 1995, and Four-Peaked Mountain in Alaska, which before its September 2006 eruption, had not erupted since before 8000 BC and had long been thought to be extinct. Technical classification of volcanoes: volcanic alert level. The three common popular classifications of volcanoes can be subjective, and some volcanoes thought to have been extinct have erupted again. To help prevent people from falsely believing they are not at risk when living on or near a volcano, countries have adopted new classifications to describe the various levels and stages of volcanic activity. Some alert systems use different numbers or colors to designate the different stages. Other systems use colors and words. Some systems use a combination of both. Volcano warning schemes of the United States. The United States Geological Survey has adopted a common system nationwide for characterizing the level of unrest and eruptive activity at volcanoes. The new Volcano Alert Level system classifies volcanoes now as being in a normal, advisory, watch or warning stage. Additionally, colors are used to denote the amount of ash produced. Details of the U.S. system can be found at Volcano Warning Schemes of the United States. Decade volcanoes. The decade volcanoes are 17 volcanoes identified by the International Association of Volcanology and Chemistry of the Earth's interior as being worthy of particular study in light of the history of large, destructive eruptions and proximity to populated areas. They are named decade volcanoes because the project was initiated as part of the United Nations-sponsored International Decade for Natural Disaster Reduction.